My name is Althea B. Villarino, Bachelor of Secondary Education, major in Science, first year, Block B. So the second question is, by how many newtons do you increase the weight of your car when you fill up your 11.5-gallon gas tank with gasoline? A gallon is equal to 3.788 liters, and the density of gasoline is 737 kilogram per cubic meter. So in this question, we want to find out how much weight of the car would increases if its gas tank is full to 11.5 gallons. So the stated quantities are the volume, which is 11.5 gallon, and it is stated in the problem that in every 1 gallon it has an equivalent of 3.788 liters, which is then converted into cubic meter, arriving at the value of 3.788 times 10 to the power of negative 3 cubic meter. And the density of the gasoline, which is 737 kilogram per cubic meter. So the problem is asking for the weight of the car. So the unknown is the mass. To calculate the mass, we must first convert the volume of the gasoline gas tank, which is calculated into V equals 11.5 gallon times 3.788 times 10 to the power of negative 3 cubic meter over 1 gallon. I arrived this equation since in every 1 gallon there is an equivalent of 3.788 times 10 to the power of negative 3 cubic meter. So cancel out the gallon, and inputting this in calculator, we arrived the product at 0.043562 cubic meter. So this is the converted volume of the gas tank. With this converted volume, we can now proceed in finding the weight of the car, which is the formula mass equals density times volume. Given the density, which is 737 kilogram per cubic meter, times the converted volume, which is 0.043562 cubic meter. Calculating this, we have the product of 32.105194 kilogram, since we cancel out this cubic meter. So this is the mass of the car. But this is not the final answer, since This is not the final answer since the problem is asking for the Newton. So, to convert this into Newton, we have in every 1 Newton, there is equal to 1 kilogram times meter per second squared. So, the formula in conversion is weight equals to mass times accelerated gravity. So, given the mass, which is 32.105194 kg, times the accelerated gravity value, which is 9.8 meter per second squared. Calculating this, we have arrived at 314.6309012 Newton, since 1 Newton is equivalent to 1 kg per times meter per second squared. So this is the calculated, so this is the conversion of the mass, but this is not the final answer since the least significant number in the given were only 3. So we have to make this value into 3 significant number. So we have the final answer at 315 Newton.